Hello girls, now we'll work on problem 5.11.1 from chapter 5, Forces chapter. So this problem is telling you that there is a saucer and a cup on top of it, and they're all resting on the table. Okay? So, what do we know? About the cup, let's call it object 1. We know that the mass is 0.176 kilograms. We know about the saucer, or let's call it object 2. M2, or the mass of the saucer, is 0.165 kilograms. Calculate the magnitude of the normal force on the saucer exerts on the cup. On the cup, so we're working on the cup here. That's A. So for A, we want the normal force on the cup. So let's isolate the cup. Pretty cup, looks like a box. And let's draw all the forces on it. Oops, sorry. So what are the forces acting on the cup? There is the weight of the cup, that's correct. And there is also the normal force on the cup. I'm going to call it Fn1 because I'm talking about the cup or my object number 1. Now, I know that the cup is at rest, which means the velocity is 0. So when I start working, I would say that the velocity is 0, which means, according to Newton's first law, the net force is 0. Okay, the net force is 0. What forces are applied on the cup? As we said, there's the weight, and there is the normal force, which means weight and the normal force, which are actually the net force, are equal to 0. So, from this equation, I can find the normal force, but I have one problem. I don't have the weight. Well, I can easily find it because I know that the weight is equal to the mass multiplied by gravity. So, and I do have the mass, so I substitute and I find the weight. Using my calculator, I'll find the weight to be negative 1.72, and I'll use three significant figures, because they gave me 3 significant figures. And the unit is not kittens, it's newtons. So that's the weight. Now I'm ready to substitute. W plus Fn1 equals to 0, so negative 1.72 plus Fn1 equals to 0, and the normal force is 1.72 newtons. That's my final answer. I take a minute to take a look at it. It's positive upwards, that makes sense. And I used 3 significant figures. I have it correct, so I get it pass. Now, second question, B. The table exerts on the saucer. On the saucer. So I'm working with the saucer. I isolate it, I draw it. Okay, I put a number line beside it to indicate my positive, and I write everything I know about it. Okay, so for the saucer, what forces are acting on it? There's the weight of the saucer, W2, because I called this object 2. There is the normal force by the table on the saucer. Let me make it a little bit larger. Okay? I don't know how large it is yet, so it doesn't matter how you draw it. But there's one more thing. there is a cup that's lying on top of it, pushing it down. Okay? It's like, as I said in class, when you're lying on a bed and then your little sister comes and jumps on you and sits on you, you feel her weight on you. She is pushing you down. So, there is another force by the cup on the saucer, downwards. There's another way to understand it. There is a force by the saucer on the cup. We've just found it. Well, its reaction is force by the cup on the saucer, equal in magnitude and opposite in direction. So, do you understand now why we have another force on the saucer? Because it's the reaction of the force by the saucer on the cup. Action, reaction. Force by the saucer on the cup, force by the cup on the saucer. That completes our forces. So, again, the saucer is at rest, which means according to Newton's first law, the net force is equal to 0. Let's substitute. So the forces that we have are Fn2 and Fn1 and W. That's all. So these forces are equal to 0. Let's substitute. Fn2, I don't know it. That's what I'm trying to find, so I keep it as a variable. Fn1. Okay, what is Fn1? Remember, these two forces, the force by the saucer on the cup and by the cup on the saucer, are action and reaction. So, the force here is actually negative 1.72. And I need to explain that these are action and reaction. So I will write that down. So I call them Fn1 and Fn1 apostrophe. Plus W. W, I don't have it, so I need to go back and prepare it. W is equal to mass times gravity. It is equal to what? They gave me the mass. The mass is 0.165 times the gravity is negative 9.8, and the answer is, find my answer to be 1.62 negative. Of course, newtons. So I can substitute that now. Negative 1.62 equals to 0. As a result, Fn2 is equal to 1.72 plus 1.62, and so Fn2 is equal to 3.34 newtons. Force is positive, so it's upwards. Makes sense. And that will be my final answer.